Hey kids, what we're going to look at in these next few slides today are the how to work out some of these calculus problems, and they're not too bad, these starters. We're just trying to find just minimums, and so if we're going to do that, what we're going to do is we're just going to look for values on this graph that indicate a minimum place. Minimums occur when the y values decrease to a certain extent, and then after that one certain point they start to increase again, and that's a minimum. And when we're talking about calculus, we also need to keep in mind we have to check endpoints. If we have a closed interval, something like this, a to b, then we need to check our endpoints. If we have some sort of open interval, which would be like this, a to b, then we don't need to check our endpoints. So we have to pay attention to what's going on here. Brackets mean that a and b are included. Parentheses mean a and b are not. So if we're going to find minimums here, there's two places that I'm really interested in. One, it's this endpoint right here. Notice at that endpoint right there, I've got no values lower than this y value, okay? And so I would say that I have a minimum when x equals -5, and at that point, y is going to be equal to, and give your best guess here, it may or may not be super exact, but we can narrow it down to somewhere around 2.5, okay? Again, whatever. It may or may not work out exactly to that, but it should be close, all right? What exact decimal answers in this case on a graph without a function, hard to tell. The other place that I'm really interested in is down here where my graph stops moving down on the y-axis and starts to move up, and that looks like it's occurring at an x value of 3. So if I were to draw a line right through here, that would indicate this point would indicate a minimum value. So then I would also say that I have a minimum when x equals 3 and when y equals -3.5. Okay, so that's a little bit about minimum values. We'll look at a couple of more examples here in just a second as well that also deal with minimum values. So, but these first few guys aren't too bad. All right, check out this bad boy right here. We've got a lot going on, and if we want to find these minimum values again, there's really only one place in here, and that would be the valley of this particular graph. So there's one valley, and it looks like it occurs at 1. So if you just kind of draw a little asymptote down, you should split this valley right into, and that's occurring right here. Okay, so let's talk about something else real quick. If this is my minimum value, and that's going to be when x is 1, y is -2, let's talk about absolute minimum value. And absolute minimum value says that we have a y value on our x-axis, on our graph, that we just don't go past at all. In fact, it's the lowest y value on the entire graph, and we know that for a fact. Well, if you compare this slide to the previous slide, we had endpoints on that previous slide to check. And with this one, there's no endpoints. We have this graph going right here, but it doesn't indicate that it stops in either direction, okay? And so if we are looking, say, for an absolute minimum, hey, this just does not exist on this particular graph. Do we have local minimums? Yes. Do we have local maximums? Yes. But an absolute y value that we just don't go below, that doesn't exist. But same thing for an absolute max. On this particular graph, it does not exist. Okay, this time we don't have a graph, but we're asked to find the extreme values of this function. And in order to find extreme values, we have to start with a derivative. So we're really interested in what g prime of x is going to be in this case. And that's going to be -2x plus 10. Okay? And to find extreme values, what we're going to do is we're going to do two things. One, we're going to set the derivative equal to 0 and solve for x. And then we're also going to check our endpoints. These endpoints are included. We're going to check our endpoints as well to find out if we get any max or min values. To go ahead and solve this guy for x, we're going to have -2x equals -10. So x equals 5. That's point of interest number 1. Point of interest number 2 is x equals 3. And point of interest number 3 is x equals 7. So once I know what all these things are, I need to look at what the function is, the original function is, at these specific points, because that tells me what my max or min values are going to be. So I need to know f of 5. Well, either put it in your calculator or work it out by hand. -5 squared plus 10 times 5 minus 21. I also need to check f of 3, which is going to be 3 squared plus 10 times 3 minus 21. And then I need to also check f of 7. F of 7 is going to be negative 7 squared plus 10 times 7 minus 21. So now it's just a matter of working these guys out mathematically. And once we know what the y-coordinate is here, we'll know if we have maxes or mins. So let's start on top. I've got negative 25 plus 50 minus 21. And negative 25 goes with positive 15, gives me 25 minus 21. So this guy is going to be a 4. So the point x equals 5, y equals 4 is on my graph. Down here, I've got negative 9 plus 30 minus 21. Negative 9 plus 30 is 21 minus 21. So hey, this guy is going to be 0. So at the point 3, 0. And then lastly, I've got negative 49 plus 70 minus 21. Negative 49 and 70, that's 21. Minus 21 is also 0. So at the point 7, 0. Now look at this for just a second, and let's just pay attention here. Maximum values are y values that we don't go past going up. And in that case, that's this guy. He's a max. Minimum values are y values that we don't go past going down. And check it out. 0 is definitely less than 4. So this guy's a min, as well as this guy down here. So that's finding all the extreme values for a particular function. Okay, now this problem, finding the extremes, is going to be a little bit more challenging because it's a trig function. We still have to follow the same exact steps. We need to find derivative and set derivative equal to 0, but we're now going to have to rely on some of our trig knowledge to finish this guy up. So derivative, again, super important when you're trying to find max values as well as the endpoints. So f prime of x is equal to negative sine of x minus pi over 8 times the derivative of x minus pi over 8, which is 1. So we don't need to write that down, but that's the chain rule part of that. And we want to set this guy equal to 0. And when we set this guy equal to 0, we just need to ask ourselves, at what values on our unit circle do we get 0 for the sine? That's what we really need to know. Forget about inside this guy for just a minute. Where do we get 0? Well, remember your unit circle. Just real quick, we've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's a bad 0. Okay? These are our points. Well, when we are on the x-axis, our y-coordinate is 0, which means that the sine is 0 when we're on the x-axis. And where does that occur over this interval? From 0 to 7 pi over 4, which is right here. 7 pi over 4 is right here. So we're looking on this interval. Okay? Where do we get zeros? Well, we get zeros at 0, and we get a 0 at pi. So what I'm going to do is I'm going to set this inside angle right here, x minus pi over 8, equal to 0, because that's where sine is equal to 0. I'm also going to set x minus pi over 8 equal to pi. The reason that I do this is because when I substitute these values in 0 and pi, that gives me the actual trig angle that will create a 0 inside of for my sine. So I'm just going to solve this guy out. He's not hard. So x equals pi over 8. And think about this. Put pi over 8 in there for x. Pi over 8 minus pi over 8 is 0. Okay? So that works. The other one, though, is a little trickier. We're going to add pi over 8 to both sides. So let's go ahead and remember that if I have pi and I'm working with fractions, this is the same thing as 8 pi over 8. And when I add pi over 8 to both sides on that guy, I get 9 pi over 8. All right, so that's pretty cool. Check it out. When I put 9 pi over 8 in for x, I get 9 pi over 8 minus pi over 8, or 9 pi over 8 minus 1 pi over 8. That gives me 8 pi over 8, which reduces to pi, and the sine of pi is 0. So what I've got in both of these cases, I've got y values of 0 and y values of 0. Okay, so these are minimums or maximums. All right. Now the other thing. Whoops, I don't have y. I have. We'll find y in a second. The other thing I need to do is check my original my original endpoints, 0 and 7 pi over 4. The reason I need to check those is because you could potentially have maximum min values at those endpoints. And in this case, pi over 8, you know, if I check all this out now, so I'm going to have cosine of pi over 8 minus pi over 8. That's the cosine of 0. So I have an extreme value at the point pi over 8, 1. When I check out 9 pi over 8, so that put 9 pi over 8, and for x into the original function, minus pi over 8. Whoops, 8. This gives me 8 pi over 8, and the cosine of pi is negative 1, so pi over 8, negative 1. And now what we have to do is we kind of have to investigate what's going on at these two other endpoints. Well, we're not super handy with pi over 8s. But we do have cosine of 0 minus pi over 8. Okay? And when I do that, I'm going to take the cosine of negative pi over 8. Well, go ahead and put that into your calculator because that's not something that we carry around that we should have memorized. Okay? So I'm just going to go into my calculator. I'm going to make sure that I am in radian mode, because we're dealing with pi over 8. That's a radian measure. So I'm going to just change that real quick. And then I'm going to plug in cosine of negative pi over 8. And that gets me a y value of 9.92. So on this one, when x is 0, 924, we'll round it at the third decimal place. So what do I have? I have at the point 0 a y coordinate of 0.924. That's one endpoint. That's one endpoint. The other endpoint occurs at 7 pi over 4 minus pi over 8. And just real quick, let's check and see if that's one that we would know. 7 pi over 4 minus pi over 8. And when I do this, I need 8s, so that's 14 pi over 8 minus pi over 8. Gee, I don't think this is one we're going to know. So that gives me 13 pi over 8. Well, what I'm going to do then is just come down here and go, all right, cosine of 13 pi over 8. And again, this will give me another point just to investigate, to tell me what's going on. So I'm going to punch this into my calculator. And I get the point 13 pi over 8. And I get the point, let me go ahead and clear this little guy off right here. I need a little bit more room for my decimal. 0.383. Now, just look at your values for just a second. I have a maximum right here because it's a large y value, okay, taller than all the others. I also have a maximum right here at 0.94 because that also is a large y value. I have minimums at -1, and that's my absolute lowest value, so that'd be my absolute min. And I also have a minimum at 0.383. And the reason this is a minimum is because it's less than 0.924. Okay, so this is kind of a little bit of a longer problem than maybe you anticipated, but it's not bad. We're just trying to check where our derivative is equal to 0 and where our endpoints are equal to 0. Okay, on this guy, this is another problem where we want to find extreme values, but this time we aren't given any specific intervals to check out. We're just given one function. And so what we're going to do is we're going to take the derivative of this function and set the derivative equal to 0. So we want to find f prime of x, and that's going to be -12x cubed plus 60x squared minus 72x, and then the 4 is going to be a 0. So when I set this equal to 0, I don't know how to solve it like it's given to me, but I do recognize that I have a factor of negative 12x in each piece. So I'm just going to factor out negative 12x, and inside this parentheses then, that gets me a positive x cubed minus 5x plus 6. Hey, all of this is going to factor. So I'm going to have negative 12x times x minus 3 times x minus 5. And I'm going to check all of those guys against 0. So 12x equals 0, x minus 3 equals 0, and x minus 5 equals 0. So this is going to give me an x equal to 0, an x equal to 3, and an x equal to 5. So those are the places where my maximums occur. So at what value, actually this should not be 5, this should be 2, because 3 times 2 is 6. Good thing I caught that. So let me just 2, 2, 2. So then what we're going to do is we're just going to run all these values through that original function and determine what we've got. So we're going to look at f of 0, which is going to be negative 12 times 0 cubed plus 60x squared, which is 0 squared, minus 72 times 0. Whoops, that was the derivative. Gee whiz. Let's get rid of that guy. We want to look at negative 3 times 0 to the 4th plus 20 times 0 cubed minus 36 times 0 squared plus 4. And when we get done checking that guy out, we're going to get the point 0, 4. Hey, we like that. That's easy money. That's what that is. Then we're going to check at 3. So I don't know if 0, 4 is a max yet or not, but I'm going to find out real quick. So I'm going to have negative 3 times 3 to the 4th plus 20 times 3 cubed. You're probably going to need a calculator. Minus 36 times 3 plus 4. So if you'll just punch that into your calculator, we'll find out exactly what we've got here.
Oh, this is calc stuff. I was like, we're already past 4.1 and 4.2.
Yeah, and I'm recording. Thanks. Right.
Do you have any maturing precipitation yet?
X cubed minus 36 times 3 squared plus 4. So this guy's going to give us negative 23, so the point 3, negative 23. And then the last guy we're going to check is 2. F of 2 equals negative 3 times 2 to the 4th plus 20 times 2 cubed minus 36 times 2 plus 4. So go ahead and punch that guy into your calculator.
Wait, is this your
And what you're going to get is the point 2, negative 28. So when you look at these guys, we have a max value right here. We have a max value right here. Our lowest min value is right here. That's where we've got a situation where we're not getting any lower. So we're not getting any taller, we're not getting any lower. The weird part is this guy right here. And this turns out that this guy is also a maximum. And you can graph him and check it out too. Graph the original function and take a look.